React Native developers. When scrolling Dribbble, I stumbled on this fun example of a rotary dial. Some of you have memories of using a physical phone with such a dial, and some of you have never seen this before. And so here we are, the most impractical way to log in on a mobile app, and yet the recipes we're going to use to elegantly implement such a user interaction are nothing but practical. Guys, I hope you are well. William here, recording from beautiful Zug, Switzerland. In the last video, we studied the basic of trigonometry in the context of mobile apps. And in this video, we're going to put this knowledge to use by implementing this fun user interaction in React Native. So how would we do this in React Native? First, we draw an arc circle that we will rotate. Then we need to build the holes in that arc circle. There are two ways to do it. First, we can draw a path programmatically that has holes inside of it, but it's a fairly complex path to compute. A much easier solution is to use a mask. We draw white holes as a mask and apply it on the quadrant. We have the quadrant with the mask applied, and then the quadrant without the mask as an underlay. From there, we need to build the gesture to move the dial around. We take the X and Y position of our finger, we convert it into a polar coordinate that gives us the angle we need to use to rotate the dial. And there are a couple of things we need to consider. First is that we want to block the dial in one direction at the 0 position, like a real physical dial. For each frame, we remember the position of the last frame. If we come from the bottom of the circle, meaning that the last angle was greater than 1.5 pi, we want to clamp the value, the next value, to 2 pi, to maximum. So we don't want to be able to go above 2 pi, just like a real physical dial. And if we come from the other side of the circle, meaning that the value is less than pi divided by 2, we want to clamp the value at 0. So we are not able to go to the other side of the circle, just like a real physical dial. Before we jump into VS Code, one thing, if you're interested to learn the fundamentals of gestures and animations, I hope that you will check out my online course at startreactnative.dev. My goal with this course is to provide you with all the tools and knowledge necessary in order to build incredible user interactions in React Native that will run at 60 FPS even on low-end devices. So if you're interested to learn the fundamentals, I hope that you will check it out at startreactnative.dev. And if you're already a subscriber, you might want to watch this video till the end. We are into VS Code here, and I have a boilerplate project which you can download from the video description in case you want to code along with this example. I have an arc circle here, and you see I can, for instance, update the value, and you see that it updates the length of the arc circle. And here I have the holes, so the component is called digit. So these are the black holes that we see on screen, and we're going to use them as a mask. So we can apply the quadrant on the mask. So here I can put on top of my design the quadrant. So you see, so it's going to be the underlay. We have it here, and it's going to be the overlay as well, but we're going to apply the mask. So let me move these digits around to a mask. So we have our definitions, and I'm going to create a mask. We can name it mask. And we want the mask to be white. So the white pixel will be the one which are visible. So I can simply put it into a group and apply the mask. So you see, now we have the holes properly done. And I think we simply are going to build a gesture to rotate the dial around. So we need a theta value to rotate. So I'm going to create a shared value named theta. And so I can pass it to the gesture component. So which is empty for now. We just have an animated view that is of the size of the quadrant. This is the one we're going to use for the gesture. So I have theta, which is an animated shared value. And so we're going to wrap this animated view into a pan gesture handler, as we always do. And we're going to create a gesture event. So use animated gesture handler. And so we said when the gesture is active, we transform the x and y coordinate into a polar coordinate, and we assign it to theta. So on active, we take the x and y value. We get the polar coordinate. So we do canva to polar on x, y. The center here is, so size is 2 times radius. So the center is at x equals radius and y equals radius. Again, in the Canva coordinate, the y-axis is inverted in compared to a Cartesian coordinate. So the center is at radius, radius. So that gives us the proper polar coordinate, and we can assign it to theta. Theta.value equals polar.theta. And so let me maybe do the proper import. Of course, if you want to test that this works, we need to actually rotate something. And I think we're going to rotate the arc circle here. So I think actually I can move it to an animated circle. And so something interesting I noticed while playing with SVG and Reanimated 2, SVG elements don't support the same API than React Native. In Redash, we ship functions to go from one to the other. So you can write React Native transformations, convert it into an SVG transformation and vice versa. But when the element is animated, here we can use directly the React Native Transform API, which is what we're going to do here. There is one difference, is that in Reanimated, the default origin is the center of the element we move. In SVG, so in SVG React Native or SVG Web, the default origin is always the top left corner of the element. So we're going to need to transform the origin to be at the center of the screen, center of the dial. So transform origin, center, and we can apply rotate theta.value. I can add region, but I think that should be the default unit. Probably need to import this guy. Doesn't appear to be moving, and it's because you might have seen this already. This is an animated property, so I need to use animated props. So use animated props, and I usually never make this mistake, but I guess I've spent so much time writing Remotion code, I forgot how to do it with Reanimated 2. So animated props equals use animated props, and we can return the transform. No. Something like this, up. So it rotates nicely. It's just, you cannot see my finger here, but we just need to invert the rotation. So now it moves nicely follows the position of my finger. And the first thing we want to do is to block the position at 0 like a real physical dial. And so one thing we're going to need to do is to keep the theta value for the previous frame. And we're going to do it using the pan gesture handler context. The context in a pan gesture handler in Reanimator 2 allows us to keep state across different states of the gesture. And so here, after each frame, we're going to keep the theta value. And so here, again, I think we have the default generic type, so pan gesture handler, and then we can declare our context. So we're going to keep a value, we're going to call it offset. So here we can keep, so we can have offset, so context dot offset equals theta dot value. Let me import this type, and we can do it on start as well. So up. And here we can block the value depending on the previous value. The previous value being context.offset. So we can call this block value. And one thing I want to do as well is that here Canva to Polar returns values that go from -pi to pi, but we want, so going from 0 to 2 pi, so normalizing the values is going to be tremendously helpful going forward. So this is what we're going to do, and redash ships functions for that. So we're going to go from -pi to pi to 0 and 2 pi. So that function is called normalize regions. Just gonna simplify the math dramatically. So it's dot theta. This one I can call new val. And so we can work on the block value function. So we have old value, new value. And so the first thing we can do is return new value. And it's a worklet function because we execute it on the animation thread. Now there are a couple of true conditions for which we don't want to return a new value. This first condition is if old value is greater than 1.5 pi, so we're on the bottom right quarter of the circle, so it's greater than 1.5 pi, and the new value is above 0, so this is what we want to block, this is where we want to clamp, so new val is greater than 0. Let me import pi. Up. Here we want to return 2 pi. But also, or if the value is 0, so at the start, we also want to block at 2 pi. So we are only able to go clockwise. So if old val, no, new val equals 0. And if, so now we need to block on the other side. So if we come from the other side, so if the old value is less than pi divided by 2, so the top right quarter of the circle, and we try to go to the bottom right quarter of the circle, meaning that new val is greater than 1.5 pi. We want to return 0, but we don't want to return 0 because then we will fall back into this case. We want to return almost 0, something like this. Let's have a look. So this is not working at all, and I think it's because we have new val that is greater than 0, but that's what I wanted to check. So it's above 0, but it needs to be less than pi divided by 2, which is what we wrote here. So to make sure that it's on the top right quadrant. So I think this should do it. So yes. So you cannot see my finger, but here the value is blocked like it would be blocked on a physical dial. So I can only go in one direction. And then it's blocked if I come from the other side. That's perfect. Now, one thing we need to do that we're able to rotate this is also to rotate the mask, because you see it looks strange. And then we need to deal with releasing the gesture and bringing the value. So first, let me rotate the mask quickly. So we're gonna have an animated group. And it's essentially the same than this one, but we need to copy the use animated props. I think in the next version of Reanimated, we don't need to copy it. We have shared animated props and styles. But here I think that we need to do it. And animated group I can create quickly. So it's called animated G. So you see here it looks as expected. So it looks and feels really as expected, like also a physical device. And now we can spring when releasing the gesture. And I think here on end, we can spring to 2 pi, I think. So theta.value equals with spring to 2 pi. And this is where you see it's very convenient to have all the values positive going from 0 to 2 pi. So here I can release the gesture and it seems to, yeah, perfect, going in the right direction. Looks and feel very cool. Now let me maybe make a bit bigger value here, and now we can create another animated value to contain the passcode, which is a string, and we can pass it to the gesture. So when we end the gesture, we can add to the passcode. So we have it here. So when we end the gesture, let's see if we can calculate the value. So we have theta.value that we can divide by delta, and delta is the angle between two numbers. That's what we used. So if we go into quadrant, that's what we used to draw the numbers. So we know exactly by how much of an angle each number are separated, and we need to round it to have an integer. And let's just print it, see what we got. See if our math is correct. So here, So let me reload. So here we have 9. Okay, so it gives us 8. So maybe I do 5, it should give us 4. So okay, we just need to do plus 1. And there's one last thing that you see, it goes to not from 0 to 10, but from 1 to 9 plus 0. So if it's 10, we need to return 0. So we can do passcode dot value is a string, and if value is 10, we return 0. Oops. If not, we return value. Val. And we can try the passcode. I have a component to try it out called status. We can pass the passcode as value. And I hard-coded into the component 0000 as the passcode. So now if I apply a random passcode, let's see. Oh, we forgot, sorry, we need to concatenate, of course, because we have 4 values. So let me try a random value first. The passcode is wrong. And now I can try 0, 0, 0, 0, and the passcode is correct. Isn't that fun? I hope that you enjoyed this example. Last video was on the basics of trigonometry, and I wanted us to apply this knowledge into a fun example in React Native. This type of user interaction is, I think, quite impractical to use in a real-world mobile app, but the recipes we've been using to implement such an example are nothing but practical, so I hope that they are useful to you to implement delightful user experiences in your own mobile apps. Guys, I am looking forward to talk to you soon, and until next time, happy hacking.